Assalamualaikum warahmatullahi wabarakatuh and good day to everyone. So today we will continue our next lecture with the title Vibration Based Structural Health Monitoring, or in short form SHM. Okay, for this topic we will more focus on monitor the health of structure such as bridge, sky bridge, flyover, road, highway, building, and etc. by using acceleration or by using vibration signal and acceleration sensor such as accelerometer. Okay, as you can see from this picture, this is examples of monitoring process for this bridge. Okay, to monitor the condition of the connecting rope between this bridge pole. So there are a sensor, okay, installed in this bridge, and it connected to the AQ, okay, and through the computer specific algorithm to analyze the condition of the rope, either it is in a safe condition or in a alert condition. So if it is in alert condition, it will notify the local authority either to do the repairing or do the replacement of the rope. Okay, next slide is a learning objective of this topic. So after completing the chapter, students should be able to do the following. First, principle of operation of SHM. Second, vibration excitation technique that being used for the monitoring. Third, vibration excitation equipment that involved to collect the vibration signal. And the fourth is challenge in SHM. Okay, this is the introduction video about structural health monitoring presented by Toshiba.
Structural health monitoring. It's often hard to see the damage inside vital infrastructure. To do that, you need Toshiba technology. As bridges and roads age, safety becomes an issue. It used to be difficult to detect degradation inside infrastructure. We have developed a new technology using highly sensitive vibration sensors attached to structures to detect cracking and a wide range of degradation deep inside. The new technology analyzes data and diagnoses the degradation. Monitoring previously invisible internal deterioration enables structures to last longer and ensures higher safety and security. This key technology detects elastic waves propagating through a structure. The sensor is highly sensitive. It can even detect the impact of rain striking the road surface. By analyzing the characteristics of propagated waveforms, we can see the degree of the crack inside the structure. Experiments on highway structures demonstrated the technology could reveal the location of cracking. New sensor technology enables safer infrastructure for all of us. Visualize hidden damage to infrastructure. Toshiba technology. Imagine the future. Create the future.
So from the video shown, we can see that it quite advanced technology, that which is Toshiba uses a highly sensitive sensor and even it can sense the rain of the road surface and also the hidden damage such as crack inside the road structure. Okay, this is the principal operation of vibration-based SHM. So, damage can be considered as a modification of physical parameters such as mass, M, stiffness, K, or damping, C. So, this is the examples of analysis technique. So, model analysis. So, this is the study of the dynamic properties of system in the frequency domain. Okay, and the example is a vibration of car body when it is attached to a shaker, or the noise pattern in a room when excited by a loudspeaker. So this is next is a model strain energy. So this is the method that has been proposed to estimate the model loss factors or model damping ratio of structure with a viscoelastic dampers. And this is mode shape curvature. So this is based on the difference of mode shape between damaged and undamaged structure, and this is the transfer function, and it is a mathematical formula to analyze the structural signal. Okay, next is a basic of vibration based SHM method. So the basic premise of vibration based damage detection is that damage will be alter the stiffness, mass, and energy dissipation properties of a system, which in turn it will alter the measured dynamic response of the system. Okay, so model parameters, notably frequency, mode shape, and model damping, are function of the physical properties of the structure, mass, damping, and stiffness. So therefore, changes in the physical properties will cause changes in the model properties. So use an initial measurement of an undamaged structure as a baseline, okay, for the future comparison of measured response. So an important feature of any viable damage, okay, ID method is the ability to discriminate between damage analysis uncertainties and environmental influences such as temperature or humidity. Okay, next is a critical issue in applying vibration-based structural health monitoring method. So the first issue is type and location of the sensor. Okay, we need to use the right sensors and also the right location. And the second, type and location of the excitation. Okay, so either we will use the right sensors in the right location of excitation or not. And the third is types of damage detection algorithm employed. So there are many algorithms can be used out there. So if we use the wrong algorithm, so it will produce inaccurate result. Okay, next is a vibration excitation technique. There are two types of excitation, which is one is a ambient excitation, and second is forced excitation. So for the ambient excitation, example is loading on the highway bridge from the passing traffic. So the input is come from the passing traffic. Okay, and forced excitation meaning that we force the input. For example, impact hammer, bumper, eccentric mesh shaker, electromagnetic shaker, and servo hydraulic linear inertia shaker. Okay, this is the vibration excitation equipment. So quick release device to excite free vibration by pulling the structure and releasing it. Okay, this is a pulse load generated by running a car with predetermined mass, okay, inside the car over a bumper. So pulse duration depends on the speed of the car. So they put a bumpers here. Okay, and the second is a instrumented impact hammer to create the excitation or a vibration. And this is another equipment, excitation equipment. Okay, eccentric mesh shaker, normally electrically powered, and electromagnetic shaker. So all some of the shaker are available in our FTKMP lab. And this is the servo hydraulic linear inertia checker. Okay, normally in industry they will use this servo hydraulic linear inertia checker because they have to test the heavy equipment or heavy test rig. Okay, and next is a data acquisition for SHM or DAQ for SHM. So the data acquisition portion of the structural health monitoring process involve selecting the type of sensors. Okay, either is a electronic type or is a piezo based type or etc. Okay, and the location where the sensor should be placed. Normally, sensor should be placed in the direct surface that involve vibration. And the third, the number of sensor to be used. Okay, for example, if you want to measure, for example, if you seen the previous video, the Toshiba uses more than 4 sensors, okay, in one location to measure the excitation signal. And last, the data acquisition, storage and transmission hardware. Okay, there are many types of data acquisition in the market, and also the transmission, either it uses Bluetooth, it uses cable, it uses Wi-Fi or internet. Okay, next is model parameter. Okay, so for model frequency, changes in a model frequency do not disclose special information about structural damage, and frequency change generally not very sensitive to structural damage. Okay, so mode shape vector, so special distributed quantities, and therefore they provide information that can be used to locate damage, okay, using mode shape vector. So however, a large number of sensors are required to sufficient spatial resolution. Okay, large number of sensors. So mode shape derivative such as curvature may be more sensitive to damage. And this is the damage ID using model parameter. Okay, and this is the laboratory testing of a quarter scale steel frame structure. So this is the example of the result. There are 6 cases, and meaning that the input is 6 type of input. As you can see from the result, case 1 is undamaged, case 2 undamaged, and case 3 is damaged, okay, from the input, and case 4 also undamaged, case 5 undamaged, and case 6 is damaged in the result. Okay, and this is the last slide. Okay, challenges in vibration based structural health monitoring. So many technical challenges are identified in the vibration-based structural health monitoring technique, including better use of the non-linear response characteristic of the damage system. So non-linear is a technique that you learned previous week. Okay, and next is a development of method to optimally define the number and location of the sensor. Okay, so the research team need to identify first the method to optimum the number and the location of the sensor, so that the cost can be reduced. Okay, next, identification of the feature sensitive to small damage level. Okay, next, the ability to discriminate changes in feature caused by damage from those caused by changing environmental or test condition. And next, the development of statistical method to discriminate feature of the undamaged and damaged structures. Okay, there are many types, and basically they will use statistical method. Okay, there are many types of statistical method from fundamental and basic up to advanced method. Okay, you can find the method in internet. Okay, there are many types of method. Next, performance of comparative study of different damage detection method applied to a common dataset or benchmark problem, and many others. Okay, so That's all for today lecture, structural health monitoring. Okay, hope you can understand, and if you have any inquiry, you can just ask me. Okay, thank you.